Hi everyone, this is Mrs. G, and today we're going to be dividing polynomials. Alright, I have a quick warm-up for you guys, so please pause the video and hit play when you're ready to check your answer. Alright, so here I know it might seem silly to be doing some simple long division, but we're actually going to be doing long division of polynomials, which follows the same type of algorithm as the long division that you learned in elementary school. So the setup is very important. The first number is always going to go underneath this little tabletop that you set up, and whatever you're dividing by is going to go on the outside. So you start by looking at the outside term, and you say, how many times can 6 go into 2? And if it can't go into the first term, then you treat the 2 as 24. You say, how many times does 6 go into 24? And you put how many times up top, so 4. Then you're going to multiply going around, and you put that product underneath. Then you subtract, and then of course you drop down the next term and you do it all over again. How many times does 6 go into 8? 1. Multiply, subtract, so on and so forth. So when we're doing long division of polynomials, we're going to be following this same types of steps. And just like with regular long division, sometimes you'll have a remainder and sometimes you won't, but we're going to keep going until there's no more terms to drop down. Okay, so now we're going to try the same process with polynomials. So the setup is similar to when we're just doing it with numbers. The first polynomial you see is going to go underneath our tabletop. So we have 4x cubed plus 2x squared plus 3x plus 5. When we're doing long division of polynomials, it is important that we have a term for every degree. So here we have our cubed, our squared, the first power into the 0 power. If you are missing a degree or a term, you can have a 0 placeholder. But in this case, we have all of the terms going all the way down. Your second polynomial is going to go on the outside. We also want to make sure we have all of the terms and that we don't need any placeholders. So this one we have an x squared term, an x term, and a constant, so we have no placeholders again. Alright, so to start the long division of polynomial process, we're going to be looking with this first term here. And then for this first part, we're actually only going to be working with that largest degree. So our first step is essentially to do 4x cubed, and we'll divide it by x squared. So we're seeing how many times does this go into this. So we do 4x cubed divided by x squared. If it helps, you can do that on the side. So 4x cubed divided by x squared gives you 4x. So that's how many times x squared goes into 4x cubed. So we're going to put 4x up top. Now we're going to do the multiplication step where we multiply this by all of this, and we're going to write it underneath. So I do need to multiply it by all 3 terms. So I do 4x times x squared, and that gives us 4x cubed. And then I do 4x times 3x, which gives us 12x squared. And then I do 4x times 1, which gives us 4x. And all of these terms should match. So the next step after we multiply, just like with normal long division, is we subtract. Here we do need to be extra careful. We need to make sure that we're subtracting every single term. So I like to group this in parentheses to remind myself. So we do 4x cubed minus 4x cubed, which is 0. So that first one should always cancel out. Here we do 2x squared minus 12x squared. So we have to be really careful. This gives us negative 10x squared. Remember, we're subtracting in each column. And then last, we have 3x minus 4x, which gives us negative x. So whenever we're done subtracting, then just like with normal long division, we bring down the next term and then we start over. So now we're going to see how many times x squared goes into this. So we're essentially doing negative 10x squared, and we're going to divide it by x squared. and that leaves us with negative 10. So that's the number we're going to put on top. And then we're going to start multiplying, going all the way around. So remember, we do need to multiply all three terms. So negative 10 times x squared is negative 10x squared. Negative 10 times 3x is negative 30x. And negative 10 times 1 is negative 10. I'm going to group it. And remember, we're subtracting everything. Be really, really careful with that subtraction step. So negative 10 minus negative 10 gives us 0x squared. Here we have negative x minus negative 30x. So this is actually like saying negative x plus 30x. So that gives us 29x. And here we have 5 minus negative 10, which is 15. So with polynomial division, we know that we're done dividing when we no longer have anything to drop down. So if you have nothing left to drop down, again, we're done. Anything here is considered to be our remainder. So there's a few different ways that we can write our answers here. So one way to write your answer would be just like if you're doing long division, you write the answer, which is up top. So we have 4x minus 10, and then this is our remainder. So we do our remainder, this part, over what we divided by. So we would say plus 29x plus 15 over x squared plus 3x plus 1. Now you may also be asked to write your answer as a product of different polynomials. So another way to write it is you start by writing the polynomial that you started with, that first polynomial. So you would say 4x cubed plus 2x squared plus 3x plus 5. So this polynomial on the inside should equal this times this, whatever you divided by, times your answer, plus your remainder. So you could say equals x squared plus 3x plus 1 times your answer, 4x minus 10, and then you have to do plus your remainder, which is 29x plus 15. So again, this is just a different way to represent what your answer is. I usually like to write it like this. So again, this is your answer, and then this is your remainder. Or again, you could write it as your starting polynomial equals the product of your two answers plus your remainder. All right, let's try another one of these together. So let's start with the setup. Here, again, that first polynomial is going to go underneath your tabletop. So we have 9x to the 4th plus x cubed plus 11x squared. And here you might notice that we jump straight from x squared to your constant. So we're actually missing that x term. So to fix this, it's really easy. We're just going to give it a 0 placeholder. We're just going to say plus 0x, and then we have minus 4. And you'll see why that placeholder comes in handy. And then whatever we're dividing by is going to go on the left side. And again, here we jump straight from x squared to our constant. So we actually need another placeholder, a 0 placeholder here. And now we're ready to start the process. So we start by doing 9x to the 4th divided by x squared. And you can do it on the side if it helps. Divided by x squared will give us 9x squared. So that number goes on top. And then we're going to multiply this by all of these and put it underneath. So we do 9x squared times x squared gives you 9x to the 4th. 9x squared times 0x gives you 0. We'll say 0x cubed, so you can see that the terms match up. So we have something to add with the other x cubed term. And then we have 9x squared times 16. which gives you 144 x squared. So from here, we're going to subtract. Just be really careful. Remember, we're subtracting every single term. So we do 9 minus 9 gives you 0x to the fourth. X cubed minus 0x cubed just gives you x cubed. And here we do 11 minus 144. So this gives us minus 133 x squared. Please be careful that you're subtracting in every single step. And then we're going to bring down our next term. Even if it's a 0 placeholder, that's okay. And then we're going to start over. So here we're going to do x cubed divided by x squared. And we get x, so that's the number that's going to go on top. And then we're going to multiply x by all three and place it underneath. So x times x squared is x cubed. X times 0x is, we could say 0x squared, so our terms match. And x times 16 is 16x. And now we're going to subtract. Remember, I like to put parentheses here to remind me to subtract everything. X cubed minus x cubed is 0. Negative 133x squared minus 0 is negative 133x squared. And here, be careful. 0 minus 16x is negative 16x. And we do have one last term to drop down, so this will be our last round. So let's start by doing negative 133x squared divided by x squared. And that gives us negative 133. And then we're going to multiply. So negative 133 times x squared is negative 133x squared. And then we have plus 0x. We multiply here. And then here we have negative 133 times 16, which gives us negative 2,128. And again, we are subtracting everything. So here, negative 133 minus negative 133 actually gives us 0, so that cancels out. Negative 16 minus 0 is negative 16, so negative 16x. And then negative 4 minus negative 2,128, be careful there, actually gives you positive 2,124. So since we are done bringing down terms, we have no more terms to bring down. We know that we're done with the process, so we do have a remainder. So again, one way to write your answer, of course this number or this polynomial on top is our answer, 9x squared plus x minus 133 plus our remainder. So we do whatever this is. So negative 16x plus 2,124 over whatever we divided by, and you no longer need that placeholder for your answer. Notice if this part of your answer is negative, just leave the negative up top. I'm always going to add my remainder. So this is one way we can write our answer. Or we can write it out as a product of our answer. So we could say the original polynomial, 9x squared plus x cubed plus 11x squared minus 4. So this should be this times this plus our remainder. So x squared plus 16 times 9x squared plus x minus 133 plus our remainder, which was negative 16. So here we can say minus 16 plus 16x plus 2,124. So again, just a different way of expressing the result, but this is how I prefer to write it because it does give us what the actual quotient of our division is. Okay, so at this point I'm going to ask you to pause the video and give it a try on your own. Be careful for missing placeholders, so you will need a 0 placeholder here. That's your hint. And make sure you're just looking at the 2 examples we did. Just try to replicate the steps, and we can check your answer in just a few seconds. Alright, so let's check our work. So first thing to check is that you have that 0x squared for that placeholder. That is really important. And then you can kind of check the different steps. So this first term should be 5x, and you multiply. So then check this row. Probably the first time I would see mistakes are with these 2 numbers right here. So check here. Remember, we are subtracting, so it's 0 minus 30. So this should be negative 30x squared. That would be a really common mistake. And here it's 8 minus 5, which is 3. So check those 2 numbers. Then you bring it down and you start over. So this next term, if you do this divided by this, it gives you negative 10. Check the next row, and again, we're subtracting. So the next place to check for mistakes would be here. Negative 30 minus negative 30 is 0. 3 minus negative 60 is positive 63. Here, negative 12 minus negative 10 is negative 2. So check that subtraction step. That's usually where I see mistakes. And we're done since there's no more terms to bring down. So here's the part of our answer plus our remainder. So we always do this over this. All right, I have another one for you to try. So pause the video, give it a try on your own, and again, be careful about any missing terms. All right, so go ahead and check your work. First thing to check for is that 0x squared placeholder. Then again, just check going by each number in each row, but the subtraction steps is usually where I see the most mistakes. So again, here, 5 minus 12 gives you negative 7. 0 minus 48 gives you negative 48. Same thing in the next round of subtraction. Negative 48 minus negative 14. And here it's 2 minus negative 56, so actually positive 58. And same for that last row of subtraction. So again, that's the place to be really, really careful about. And then here is your final answer. All right, so now we're going to learn a different way that we can divide polynomials. It's definitely a lot quicker and easier. However, it only works for a specific form. So it only works if you're dividing a polynomial by a binomial, so x plus or minus a. But if you do have this case, it's much quicker and easier, I think, than using long division. So the setup is kind of interesting, so we're just going to kind of go with it. The first thing we're going to do is we're going to be taking the coefficients from our first polynomial. So just the coefficients. So the coefficient of x cubed is 7. And notice we are missing an x squared term, so we are going to put a 0 there. And then the coefficient of x is negative 6, and then our constant is 9. And then I'm going to leave a space here, and then I'm going to draw a line. And then last, I'm going to put a little box over here in the corner. So in the box, we're always going to put the opposite of the number we see here. So if I see a positive 5 here, we're actually going to put a negative 5 in the box. So again, this would be like a factor that we're dividing by. If the factor is x plus 5, the reasoning down the line is that the 0 would be negative 5. So it's always the opposite number here. Now from here, it's really just a process of multiplying and adding. So our first step is always going to be the same. We always start by dropping down this first number, 7. And then we're going to take the number in the box, we're going to multiply it by this number, we're going to write the product here, so negative 35. And then we're going to add vertically. 0 plus negative 35 is negative 35. And then we're going to do that same thing over again. We're going to take our number in our box, we're going to multiply it by this number, and we write our product here. Negative 5 times negative 35 is 175. And then we're going to add vertically. So this gives us 169. And again, we're going to multiply. Negative 5 times 169 is negative 845. Add vertically, and that gives us negative 836. So these are going to be the coefficients of our answer. So one thing is, this last number here, we can put it in a little box like this, will always be our remainder, always, no matter what. And then the rule is you take your original polynomial and you drop the degree down by 1, and that's going to be the start of your answer. So since this was x cubed, our answer is going to start with x squared. So it's 7x squared, and then it's just descending order. Minus 35x plus 169. And then our remainder, we can say plus negative 836 over whatever we're dividing by, x plus 5. And there you have it. Now you would get the same exact answer if you did long division. This is just a lot quicker. So again, make sure your setup is correct, and when you write your answer, you always take your original polynomial and you start with 1 degree lower, and then you just go descending order. You should have enough spaces for 1 for each term plus a remainder. Sometimes your remainder will be 0. All right, let's try another one together. So again, we can use synthetic division because we're dividing by the binomial. So here, let's do our setup. We're going to list out our coefficients. So we have 4x to the 4th, 0x cubed. Be careful, we're missing a term. Negative 3x squared, 7x, and 2. And then the number in our box is always opposite of this number. So we're going to put positive 1/2. So drop your first term, and then we start the process. 1/2 times 4 is 2, and then add vertically. 0 plus 2 is 2. 1/2 times 2 is 1. Remember, multiplying by 1/2 is just dividing by 2. Negative 3 plus 1 is negative 2. 1/2 times negative 2 is negative 1. Add vertically, you get 6. 1/2 times 6 is 3. And then we add vertically, and we get 5. So 5 is going to be part of our remainder. And since we started with x to the 4th, our answer is going to start 1 lower with x cubed. So our answer is 4x cubed plus 2x squared minus 2x plus 6 plus our remainder over our divisor. And there you have it. Alright, so this time I'm going to ask you to pause the video and give one a try on your own. And we can check your answers in just a few moments. Alright, so go ahead and check. So here you have your coefficients. Just remember, this box number is always the opposite, what you see in your factor. And then here's your answer. You should have that remainder of 41 over x minus 2. Alright, go ahead and give this other one a try. So again, please pause the video and give it a try on your own. Alright, go ahead and check. One thing hopefully you caught is that we are missing that x squared term, so you do need the 0 placeholder. And this number should be negative 1/3. So just remember, multiplying by negative 1/3 is essentially just dividing by negative 3. So this should be your final answer with your remainder. Alright, so now we're going to talk about one of the applications of synthetic division, which is called the remainder theorem. So if the remainder of a polynomial divided by a binomial is 0, then that means that that binomial is a factor of p of x. So we can use synthetic division, or I guess you could use long division, it'll just take a little bit longer, to check to see if something is a factor of a polynomial, which is going to be extremely useful for us this chapter. So again, if the remainder is 0, then it means that it is a factor because it divides in evenly. So let's see if we can use synthetic division to check to see if these factors, or if these binomials are in fact factors of the polynomial. And if it is a factor, we're going to find the remaining factors. So let's start with this first one. Again, we're going to use synthetic division. So let's list our coefficients. 1, 3, -4, -12. And then in our box is going to be -3. Remember, we're always going to put the opposite of what we see in here. Okay, so let's do quick synthetic division. Drop it down, multiply, and add. Multiply, and add, and then multiply, and add. So you can see here, since our remainder is 0, that means that yes, x plus 3 is a factor. So we have one factor of this polynomial, and now we can actually find the remaining factors by writing what we have left. So let's write this. So we started with x cubed, so this will be x squared. So we have x squared plus 0x minus 4. And then this, we know we can factor more using difference of two squares. So this becomes x plus 2 times x minus 2. And then, of course, we have that original factor which we checked, which was x plus 3. So now this polynomial is completely factored. So again, we're looking for a 0 remainder, and then we look at what we have left to see if it can be factored more. All right, let's try part B together. So again, we're going to test to see if it's a factor. So let's list out our coefficients. 1, -4, -6, 4, and 5. And our box goes -1. You'll see the more we do synthetic division, the quicker and easier it will get. So drop it down. Then we multiply and add. Multiply and add. Multiply, add, multiply, and add. So again, here we have a remainder of 0, which means that x plus 1 is a factor. So let's see what we have left. That gives us x cubed. Remember, we always start 1 degree lower than the original. Minus 5x squared minus x plus 5. So to factor this one, again, since there's 4 terms, we know to check to see if we can factor by grouping. So I'm going to group our terms. For the first 2 terms, the GCF is x squared. So let's factor out x squared. So we have x squared times x minus 5. For the second 2 terms, since this term is negative, let's just factor out a -1. That's the most we could factor out. So that leaves us with -1 times x minus 5. And since these 2 factors match, we can take the coefficients here. So that leaves us with x squared minus 1 times x minus 5. And here we do have our original one, x plus 1. But hopefully you also notice that this can be factored even more. So this is difference of 2 squares. So we can do that a plus b times a minus b. And then we have our other 2 factors. So we can actually factor this quite a bit. So this is our final answer. And if you really wanted to, since we have the same factor twice, we can actually write it like this. X plus 1 squared, and then times x minus 1 times x minus 5. So just don't forget about that original factor once you've tested. As long as that remainder is 0, it is a factor and it should be part of your answer. All right, so now I have a couple for you to try on your own. So please pause the video and give it a try, and then hit play when you are ready to check your answers. All right, so go ahead and check. Part A is actually a really great review of the last lesson we did. So when you do your synthetic division, you do end up with a remainder of 0. Be careful here, you do need that placeholder for x squared. And what you have left is 2x cubed plus 0x squared plus 0x plus 2. So I have that factor plus the factor that I just checked. So there's a GCF of 2, so you can factor that, and then that leaves you with x cubed plus 1, which is sum of 2 cubes. So this you can actually factor even more into x plus 1 times x squared minus x plus 1. So again, you should always check to see if you can factor more. Now for part B, when you do your synthetic division, we end up with a remainder of 4. So since the remainder is not 0, we just say not a factor, and we are done. All right, so that is all for today's video. Thank you so much for watching.